Hello and welcome to another math video. In this one, we're going to start looking at section 4.6, the graph of the other trig functions. We've already seen sine and cos, but there's 4 more to go. And in this video, we'll look at the tangent and its reciprocal cotan functions. And then in the next video, we will look at secant and cosecant functions. Let's dive in. It says here, well, let's do it this way. Here is pi over 2 on the unit circle, and that point is 0, comma 1. And remember that tangent is sine divided by cos. So up here, our sine value is 1, our cos value is 0, and then that would be undefined. So up here at the top of the unit circle at pi over 2, tangent is undefined. But what is it doing as we get closer to that undefined value? Well, half pi is 1.57, and it keeps going on and on forever. So what we're looking at here, we're getting close to pi over 2. 0's close, but not too close. Pi over 4, and then we get 1.5, 1.57. And you know, that's very, very close to pi over 2. What is going on with our y values? Well, at 0, our y value is 0. At a quarter pi, it's 1. At 1.5, we jump up to 14.1. When we go one more decimal spot, we're up over 1200. And you know, we could keep doing that. These numbers are going to get bigger and bigger. They're actually going to get infinitely big. And you know, right when we get to pi over 2, that would be undefined slope, perfectly vertical. So we have an undefined value there for tan. So the book says, as indicated by the table, the tan of x increases without bound as x gets closer to that half pi value from the left. And it decreases without bound as we approach negative pi over 2 from the right. So over here we can see a reflection on this side of 0, but now every value is negative. They're the same values, but they have now negatives in front of them. And that happens as we approach negative half pi. Moreover, because the period of the tangent function is pi, vertical asymptotes will occur at every half pi and then every pi radians after that. The domain of the tangent function is the set of all real numbers. The range is the set of all real numbers. Well, it says the domain is a set of all real numbers except these. These are where the vertical asymptotes are going to appear. So those are not part of the domain, but the range is all real numbers. So here's a look at the graph of tan. Notice we do have vertical asymptotes, and the function does snake in between those, heading to positive and negative infinity. When we did sine and cos, the period of sine and cos was 2 pi. So our big difference here with tan and cotan is the period is now just 1 pi. We have vertical asymptotes at half pi and every pi after that. Blah, blah. And it says sketching the graph of the tan function is similar to sketching the graph of sine in that you locate key points and identify the intercepts and the asymptotes. Okay, now here's how the book says to find the first 2 asymptotes. It says 2 consecutive vertical asymptotes can be found by solving these equations. So remember, we've got the tan of b times x, and we could have plus or minus c in there. So if we take this, what's in the parenthesis, and set it equal to negative a half pi, and set the same thing equal to positive a half pi, we'll see where these first 2 asymptotes have been shifted to. So again, let's go back up here and take a look at this basic tan graph. Notice it goes through the origin, and we have a vertical asymptote at half pi, and we have a vertical asymptote at negative half pi. What is the distance between those 2 asymptotes? Well, that's 1 pi radians. That's also the period of this function. And notice if we're at this half pi vertical asymptote, if we jump the period one more time, add another pi, we get to 3 pi over 2, and there's a vertical asymptote there. If we take 3 pi over 2 and add another pi, we'll get to the next asymptote, that would be at 5 pi over 2. So once you find one of the asymptotes and you know the period, you can jump from one asymptote to the other. So you could do this, set each of these, bx minus c equal to positive and negative a half pi, and solve those, and that will give you your first two asymptotes. Or you could solve one of these or the other, and once you have one asymptote, use the period to jump to the next one. And also notice here too that in the unshifted graph here of tan theta, that the first two asymptotes are equally spread around the y-axis. Here's the y-axis right in the middle, and we have the period is 1 pi. This is 1 pi radians, and we've done half of that to the positive side of the x-axis, and the other half of it is to the negative side. So our first two asymptotes will straddle the y-axis unless we've been shifted. So the midpoint between any two consecutive vertical asymptotes will be an x-intercept. The period of the function is the distance between two vertical asymptotes. The amplitude of the tan function is not defined. After plotting the asymptotes and the x-intercepts, plot a few extra points between the asymptotes to sketch a cycle. So let me point that out here on this also. I have a vertical asymptote here and here. Right in the middle is an x-intercept. The next vertical asymptote is at 3 pi over 2. Between any two vertical asymptotes is an x-intercept. Ooh, and I should point out here also, notice that positive tangent goes up to the right and down to the left. So down to the left and up to the right. If we were to look at negative tan, that's going to reverse. I'm just going to write it in here in blue ink. Here I am at the origin. If I have a negative tan, I go up to the left and down to the right. So that switches the which way we go up and down. Okay, let's try this one. Tan of x over 2, or that is the tan of 1/2 x. First, let's find the period. To find the period of sine and cos, we took 2 pi and divided it by the number in front of x. Because tan and cotan have a period of 1 pi, we're going to divide 1 pi by the number in front of x. That's 1/2. So we bring up the 1/2, flip, and multiply. So our period, I'm going to write it up here, period equals 2 pi. Now we could go back to here, and we could set bx minus c equal to negative a half pi and set it equal to positive a half pi. And if we do that, we're going to get 1/2 x equals, let's do the positive one first, pi over 2. Okay, how do you get rid of this 1/2? We divide by a half, or we could multiply by 2 over 1, so they cancel. So we're going to multiply this side by 2 over 1, and we get one of our asymptotes is going to be at positive pi. We could do the same thing if I set this up and solve for setting it equal to negative pi. If I make that a negative pi, we're going to multiply by 2, multiply by 2. So now we get x equals negative pi. So we're going to have a vertical asymptote at pi, and we're going to have another one at negative pi, and those would be our first two. Okay, so that's one way to find your first two asymptotes. Another way, a different way that the book really doesn't show you is, once we know the period is 2 pi, we know that that 2 pi is spread equally around the y-axis. So we could say, okay, if I got 2 pi in a period, half of that is going to be over here on the positive side, positive pi. The other half is going to be over here on the left side at negative pi. So there's another way to find your vertical asymptotes. We could also say, okay, let's say we just found this one here at pi first. We just found this one at pi, and we know the period is 2 pi, so we can use that to jump to the others. If I'm here at positive 1 pi and I jump 2 pi to the left, I'm here at negative pi, and I can draw a vertical asymptote. Let's find a couple more. If I'm at pi and I jump 2 more pi to the right, that's going to put me at 3 pi. That's a 3. And that's another vertical asymptote. And if I'm at negative pi and I jump 2 pi to the left, if I'm at negative pi and I jump 2 more over, that'll put me at negative 3 pi. And we found another vertical asymptote. Okay, in between each of these asymptotes is an x-intercept. So I'm going to have one right here at the origin. And tangent, if it's positive, goes up to the right and down to the left. And in between 1 pi and 3 pi, this would be 2 pi. And we're going to go up to the right and down to the left. And we'll have one also over here at negative 2 pi, up to the right, down to the left. Okay, now in that other slide, when I was reading the text from the book, it does say that the amplitude is kind of undefined here. If I had put a 3 in front of tan, that has a big effect on sine and cos, but that 3, all it does is change a little bit of the curvature right here. A positive number will make it less curvy. It'll go up a little quicker. If it's a fraction, it will flatten it out a little bit. But that number 3 is going to be imperceptible to the eye. It's not something I'm going to pull out of your graph and say that you got it right or wrong, because that coefficient has very little effect on the shape of the graph. All right, what's next? Ooh, now here we go, a little different one. Now, just like I said in a couple seconds ago, this 3 isn't going to do much, but the negative is going to make our graph go up and down in the other directions. So let's see, here we've got tan of 2x. Our period is pi divided by the number in front of x, that's a 2, so pi over 2 is the period. Now, one way to find our first two asymptotes, remember that pi over 2 is going to be equally spread around the y-axis because this graph has not been shifted to the left or the right. So our first two asymptotes will be spread equally around the y-axis. And what's half of pi over 2? Well, to cut a fraction in half, double the denominator. Our first asymptote is here at pi over 4, and we will have one here reflected over to the other side at negative pi over 4. So our period is a half pi, and that's the jump from one asymptote to the next. So let me go like this. We're going to jump over this way. If I'm at quarter pi and I jump half pi, 1/2 plus 1/4 is 3/4 pi. Here's another vertical asymptote. And we can jump this way. If we're at negative quarter and we jump half pi to the left, that'll take us to negative 3/4 pi. And we've got another vertical asymptote. Okay. Again, the 3 doesn't change much of the shape of our graph, but the negative does. So let's see, remember in between these vertical asymptotes, we have an x-intercept right at the origin. Negative tan is going to go up to the left and down to the right. And then here between half pi, or between quarter pi and 3/4 pi, is another x-intercept, and that's at pi over 2. And I could point out here the jump between any two vertical asymptotes is the period, and that's the same jump. Let me see if this is going to work. So here's the jump between two vertical asymptotes. That's also going to be the jump between any two x-intercepts. So if I've got one at 0, I've got one at half pi. If I've got one here at 0, I'll have one at negative half pi, and that one will also go up to the left and down to the right. So there are 3 cycles of negative 3 tan of 2x. Okay. Up next now is cotan. Now cotan is just the reciprocal of tangent. You'll see that the graph is very similar with only a couple small changes. So the graph of cotan is similar to the graph of tan. It also has a period of pi. However, from the identity, cotan is cos over sine. We can see that the cotan function will have vertical asymptotes whenever sine is equal to 0, which occurs at pi and every multiple of pi after that. The graph of cotan function is shown below. Notice that 2 consecutive vertical asymptotes of the graph can be found by solving these equations. Set bx minus c equal to 0 and set bx minus c equal to pi. Because here I like to point out, if cotan is not shifted, Your first vertical asymptote is the y-axis. And once you have your first vertical asymptote, you can use the period to jump to all the others. They say here that the period is pi, and if we have a vertical asymptote on the y-axis, we'll have another one over here at pi radians. We'll have another one at 2 pi radians. We'll have another one at 3 pi radians. So the period jump is the same as tan, but this is nicer because our first vertical asymptote will be the y-axis unless we've shifted and moved that to the left or right. So my advice is find that first vertical asymptote. Again, it's usually the y-axis. And when you have the period, jump to all the other VAs. Just like tan, between any two asymptotes will be an x-intercept. And another small change here is cotan, if it's positive, is going to go up to the left and down to the right. And if we make it a negative cotan, that will be down to the right and up to the left. So cotan is the same as negative tan. Negative cotan is the same as positive tangent as far as the up-down aspect of the graph. Let's try one. So here we've got y equals 2 cotan of x over 3, or I'm just going to rewrite that as 2 cotan 1/3 x. Okay. Again, our first asymptote will be the y-axis, and this graph is not shifted left or right. So let's figure out what the period is. Period is pi divided by the number in front of x, and that is a 1/3. Bring that 1/3 up, flip it, and multiply. Our period is 3 pi. So the period is 3 pi. That's going to make this one pretty easy. Our first vertical asymptote is the y-axis. And now we're going to jump the period to the next asymptote. So I'm going to make this far 3 pi. So I'm going to put another vertical, whoa, it's supposed to be red. There we go. A vertical asymptote here at 3 pi. And I might be able to squeeze another one in. Almost. Well, imagine there's another one here, and it's 6 pi. 6 pi. And of course, let's do one to the left. You know, if we're back at the origin, at 0 radians, here would be one to the left. This would be negative 3 pi. And you get the idea. Okay, we've got some asymptotes. Let's put x-intercepts in the middle. What's right in between 0 and 3? Well, that'll be 3/2 pi. And what's in between 3 and 6? That's 4.5, or 9/2 pi. And we'll also have a reflected one over here at negative 3 pi over 2. Okay, remember the 2 is not going to do much. It will slightly change the curvature, nothing we can perceive with the naked eye. So we've got a positive cotangent. That means from an x-intercept, we're going to go up to the left, down to the right. Up to the left, down to the right. Up to the left, and down to the right. 3 beautiful cycles of 2 cotan of 1/3 x. A couple for you to try on your own. Actually, 3 to, now this is a left or right shift, so careful. That cotan, the first asymptote, will be shifted, but once you find your first, you can jump to all the others. Okay, so pause the video and give these a try. Start it back up and see if you got them right. Okay, first up, I'm going to find the period. The period is pi divided by the number in front of x, which in this case is 3, pi over 3. Now, if you remember that tangent is equally spread around the y-axis, unless we've been shifted, and this graph is not shifted left or right. So we are going to have 2 VAs spread around the y-axis, here and here. And each of those will be half the period away. So what's half of pi over 3? We'll just double that denominator, pi over 6, and negative pi over 6. Okay, let's jump to the next vertical asymptote. So, excuse me, I'm going to drop the pi for a minute. So we're at 1/6, and we're going to add 1/3. Well, we need a common denominator. Let's multiply by 2. So that would be 2/6 plus 1/6 is 3/6 or 1/2. So our next jump is going to take us to pi over 2. So this is positive pi over 2. Because we're not shifted, we will be symmetric around the y-axis. So over here will be a negative pi over 2. And we've got 3 cycles going so far. So let's see, here we're going to have a y or an x-intercept here at the origin. And we can jump the period to the next x-intercept. So if we're at 0 and we do that jump, that will be to pi over 2. Excuse me, pi over 3. Pi over 3. I'm looking up here. There's the period. And the same thing to the left. This will be at negative pi over 3. Okay. Last step. We're going to take the negative and draw our lines. Negative tan is going to go up to the left, down to the right. Up to the left, down to the right. Up to the left, down to the right. Okay, let's get that other one out of the way down here. Tan of a third x. Now notice this one's not negative. And here we have a fraction in front of the x. Now this is a whole number. So that's going to have quite a little change on our graph. So for this one, the period is pi divided by the number in front of x, and that's a 1/3 x. So we're going to divide by a third. Bring it up and flip it. So that's going to be the tan is, 3 pi. The period is 3 pi. So now again for tangent, our first asymptotes are equally spread about the y-axis since our graph is not shifted. So half of that period is going to be over here, 3 pi over 2. And then the other half of the period is going to be over here, negative 3 pi over 2. Where again, remember, you could just say, okay, I'm going to set x over 3 equal to pi over 2 and solve that. And set it also equal to negative 3 pi over 2 and solve that. That will also get you these first 2 asymptotes. Let's find a couple more. So if I'm at 3/2, and I'm going to add to that a jump of 3 over 1, or we could think about that as 6 over 2. 3/2 plus 6/2 is 9/2. Our next VA will be at 9/2 pi. And we will also see the one over here reflected negative, because this is symmetric about the y-axis. Negative 9 pi over 2. X-intercepts go right in the middle, so we got this one at 0. We can jump the period to the next one over here. This would be at 3 pi. And if we're back at the origin, we could jump to the left to this x-intercept at negative 3 pi. Okay, this is positive tan. Positive tan from an x-intercept will go up to the right and down to the left. Up to the right, down to the left. Up right, down left. There are 3 pretty good cycles of tan 1/3 x. Okay, now here's our first one that has a left-right shift. Now here, and especially I like Cotan because remember Cotan, the first vertical asymptote is the y-axis. And let me do this so I don't have to do this with my pen. I'm going to bring in a line like this. Bam. Here is, oops, that wasn't what I wanted. Get back there. I want it dotted. So here is a vertical asymptote. And for Cotan, there we go, that usually sits right on the y-axis. So let me make that even a little thicker. Bam. So here's our first vertical asymptote. It is on the y-axis. But this x minus pi over 2 is a shift. The first vertical asymptote is usually at x is 0. So we're going to set what is in that set of parentheses x minus 2. We're going to set that equal to 0 and see which way this graph has been shifted. We're going to add pi over 2 to both sides. So pi over 2 positive is our first vertical asymptote. Or another way to think about it is, remember when we were shifting any kind of a graph, if we're in there with the parenthesis with the x, a minus is a shift to the right. So this first vertical asymptote that used to be on the y-axis is now here. I'm going to go about this far. This is pi over 2. And we can find the period. The period is pi divided by the number in front of x. What number's in front of that x? Well, there's an implied 1. So the period is 1 pi. Let's use that to jump to our other VAs. So if we're at pi over 2 and we jump 1 pi this way, half pi plus 1 pi is 3/2 pi. All right, let's say we jump to the left. If we're at positive a half pi and we minus 1, we're going to be at negative half pi. Negative pi over 2. Let's go another one. If we jump another pi to the left, we'll be at negative 3 pi over 2. All right. X-intercept, first one is at the origin. And if we jump the period to the right, we'll get to this x-intercept. That'll be at pi. If we jump to the left, this one will be at negative pi. Now, if it's cotan, remember cotan is going to go, if it's positive, up to the left, down to the right, up to the left, down to the right, and up left and down right. So as I sit back and bask in the glory that is this graph, the cotan of x minus pi over 2 is exactly the same as the negative tan of x. If I asked you to graph negative tan x, this is the exact same graph you would come up with. Okay, is that the last practice problem? Yeah, once again, the assignment here, it's not very good on WebAssign. So page 506 in the book, 4-6 day 1, these problems. Make sure you read the directions. If they say graph 2 or 3 cycles, make sure you're graphing the given number of cycles. And I'll see you in the next video where we will unpack the mystery of the secant and the cosecant graphs.